industrial and systems students at Auburn University, and we did a project in the Lego lab of the Shelby Center to beta test the sequence software to create standardized work instructions in our lab, because standardization is the key to lean manufacturing. So the first step in our project was to balance the line, because there were some problems in our lean manufacturing class with the balance line. So we first took the data that was taken from 2 different lean manufacturing labs and compared them, and we realized that there were a lot of inconsistencies between the 2 data sets. For instance, in station 15, one of the labs might have had this as the bottleneck station, and then the other lab would have it as the fastest station. So we couldn't really rebalance the line based on those that data set. So we decided to do our own time studies in these 5 stations in cell 3 of the lab. So we cross-trained on different stations and did 2 different cycles of time studies and verified that our results were correct. So we used our results from our own time studies to balance the line, and we got the cycle time of each station to be under a minute. And then we created work instructions from there. So Madison's going to talk to you about the work instructions.
So I'm going to talk to you a little bit about the work instructions. Now, we based most of what we did off of our own experience working in the lab, mostly in our lean class and some other classes as well. There were some definite problems that we had seen with the old work instructions. Like the errors were a little bit too small. Sometimes there were just things that were a little bit unclear and hard to follow. I have right here an example that you can see. And as you see, the arrows are a little bit short and they're green, so it doesn't really catch your attention that much if you just glance up at it. Also, like over here and here, there's a good amount of unused space, so we really wanted to be able to take advantage of that. So we started to work on making new work instructions, and we had really 3 main goals in mind when we did that. The first goal was we wanted there to be very clear pictures. We wanted to be able to edit them, put right arrows, so you could really see and like point exactly to a piece. And in that, we wanted to use real pictures and not, Lego, just like, I don't know how you say it, animated pictures. Just because we thought that with real pictures of how it looks here, that would be easier to connect. We also wanted to have verbiage to go along with the pictures so that you could read it and see exactly what you're supposed to do. And we wanted to be able to embed training videos into the instructions. Especially with students working in the lab and people kind of in and out, we thought that this would really help to have people move up the learning curve more quickly. So if you were getting ready to work in the lab, you could come in, or you could also look at the instructions online, and you can sit there, you can watch the video and have the instructions also right there. You can even build along with it, and it really is a very valuable tool for training. So when we started working on the work instructions, first of all, we're going to use sequence software. So I'm going to take you into the lab and show you a little bit about it.
One of the great things about the sequence software is that you can use it for document control. Once you make a revision and a document number and it's been published, that can no longer change. That document is the set document, and if anybody wants to make any changes, they must request it, things of that nature. Currently we're using Excel, which, as you can imagine, there's no document control to that at all. So anybody that's ever wanted to be ISO certified, they know that document control, quality control is key. Another thing is you're able to add value-added time information in here. So at the end of the work instruction, you'll actually see the cycle time for the station. You can also add in calculated waste time so that you can target those areas whenever you're wanting to reduce waste in your cell. And another thing is you can add parts into the software. So for example, we have part 89 right here. You can log its stock location so that the material handlers will know exactly where it is. You can write a small description about it so that they'll know what it looks like. If there's any revisions that's been made to it, you can view those previous revisions. Also, you have the ability, if there's alternative parts, to look those up and see what can be used. There's also a section so you can see the cost of it. So at the end of, or whenever you're trying to calculate out, how much whip's in the station and the price of that, you can use those numbers. So for sub-assemblies, it's pretty much almost exactly like the part screen, except you have the option to look at the bill of materials, which will show you which part numbers are needed to create the sub-assembly and the quantity that's needed. So as you can see, this is the standardized worksheet that we went with. We got a lot of good ideas from the sequence software as far as having the value added time in the work instruction, having the revision numbers, things of that nature. It's a really great layout, but some of the issues that we had with it is, for example, you can only have 6 images per sheet, and we ran into the problem where we had multiple images for one step. Another thing is we felt like there's a lot of wasted space on their work instruction sheets. As you can see, you have all this wasted space down here. And that really limited us to not having enough room for, even if we did want to install a video, if we were capable of it. And talking about the video, that was another problem, is once this is created and it becomes a PDF, the only way the video can be added to the document is if you use a PDF software, something that allows you to edit the PDF, not the actual sequence software. Okay, so the great thing about sequence, though, the thing that really intrigued us, was the fact that once a change is made to that document on the original computer by the sequence admin, it's then uploaded to web sequence. And the thing about web sequence is it can be accessed from any computer as long as you're able to access their server. So what would happen is a change would be made on the computer. It would automatically update, and you would be able to access it on, say, this computer right here. So work instructions, they don't flow through the facility in document form, in paper form. It's all virtual. You don't have as much waste as far as having to deliver the documents and things of that nature.
Okay, so as Ethan was telling you, we could do a lot of cool things with the sequence software, but there were definitely some limitations. And so what we wanted to do was kind of be able to give our recommendations to the people at Sequence, and so that they would really be able to work with us. We could work together and get something that would really be usable here in the lab. And so in the meantime, Lindsay and I created a work instruction on PowerPoint that we could pull up on this computer, and it would really show what we wanted it to show. And so as you can see here, we use the verbiage like Sequence does, but we were able to put in as many pictures as we wanted with arrows that were bright yellow so you could see them. And the cool thing is that we were able to put training video in right here, and you can easily just access this when you're standing at your station. So Brandon's going to tell you a little bit more about this.
Alright, so one of the things we were tasked with was creating training videos for future people to come down and learn, especially because down here in the lab, you're coming through with new students all the time, and they only get down here every once in a while. So we tried traditional videos, and we really didn't like those because you couldn't zoom in very closely on the part, and you had a lot of distraction with the operator actually assembling it. So we came up with the idea of using stop motion, and that's where you take a picture, you make a change, and you take another picture. So it's almost like a quick slideshow. So we did that by zooming very closely in on a part before it gets assembled. Then we assemble one piece at a time, take another picture, and then continue that process. And this allows detailed close-up pictures to be taken so the training operator can actually see what's going on without any distractions. So here we have an example of one of our stop motion training videos for workstation 15. So when you push play, it starts off with an initial piece and then it slowly adds piece by piece by piece. So that way the worker can see where the piece is being added in great detail. This helps reduce confusion and error in the process where the operator may not be able to quite determine where the exact piece is supposed to be placed. And it also can be slowed down and stopped so the worker can also get better understanding of what's going on in the video. And it also correlates along with the work instructions that it's placed in.
So all in all, we really enjoyed working with Sequence. We really appreciated the powerful tool that it is and the potential that it has. We just wish that it could be a little bit easier to customize and that some of the picture editing tools were a little bit better, but it's a great start. And we have one more bonus project that we did that we're going to show you in just a second.
Okay, so as a bonus experiment, we decided to try to make some bucket brigade instructions. Even though we did a lot of testing and took a lot of time studies to try to get the line balance, there's always going to be like that worker who's really fast, who played with Legos a whole bunch when they were really little, and someone who's moving slower. And so we just really felt like bucket brigade would be a great way to know that the work was going to be distributed evenly and that there wasn't going to be any holdups in the line. And so what we did was we divided the work down into little individual steps, and we cut them out and put them just on a long process. It's not, there's a little gap where there's a gap in pieces, but there's not a big gap, like one station work instructions, another station. It's just a continuous flow of steps. So here it is.